Okay, welcome to video 11.7. Today we're going to be talking about solving quadratic linear systems algebraically. So yesterday we did this graphically. Today we're going to do it algebraically. And this is again similar to what we've done in the past where we had linear functions that we needed to solve algebraically and graphically. So the procedure to solve algebraically for a quadratic and a linear is to first make sure that both equations are in y equals form. So this is necessary. Then you're going to substitute the linear equation in for the y of the quadratic equation so that you only have one variable left to solve in the equation. You've substituted the equation in place of y, so the y's are no longer in the equation. Then you will get your new quadratic equation into standard form so that it is in the form 0 equals ax squared plus bx plus c. Then you're going to solve the quadratic equation using one of the three methods that we've already learned. And remember that you should probably get two answers. Sometimes you'll get the same answer, so it'll only look like one. Then you must find the other variable, so in this case the y, by substituting your x answers into one of the equations and solve for y. Finally, you can check your solutions just like we've done in the past. So let's look at this first example. The first thing that we needed to do is make sure that both equations are in y equals, and I can see here that they are both in y equals, so that step's already done for me. The next thing I need to do is substitute the linear function in place of y equals for the quadratic. So this, since it's y equals, is going to go in place of the y here. So then we get this 2x plus 2 equals x squared minus x plus 2. So the next thing that we need to do is get it into that 0 equals so that all the variables are on one side, and we can then solve the equation. So then I get 0 equals x squared minus 3x. Because when I subtracted the 2x and the 2, 2 minus 2 canceled, and I was left with this. Now I can solve this any of the three ways that we've learned. So your options are to try to factor, solve using the quadratic formula, or complete the square. And I think this is a good candidate for factoring since there is an x common in both. So I'm going to factor out the x. And when I do that, I get 0 equals x times x minus 3. And now that I have two factors, I can set up my t-chart to set both of my factors equal to 0. So on the left-hand side here, I'm just going to write again that x equals 0, so there's nothing to solve there. But on the right side, I have x minus 3 equals 0, so I'm going to add 3 to both sides. So then I get my answer of x equals 3. So I have my two x values, but those are not my answers. I'm not going to circle them yet because if I'm looking for the solution to a quadratic and a linear function, that means that I need a point. Right now I only have x values. So if I have x and I need y, I need to substitute that x value in to get out a y. And I think that the best candidate for that is my linear function because that's going to be easier to solve for than if I would have subbed it in for the squared, just because I'd have to put the squared in and then another x. So I'm just going to use the y equals 2x plus 2. So when I use that, I'm going to substitute in the 0 first. So I will have y equals 2 times 0 plus 2. And I get my y value of 2, and then I'm going to do this again a second time for my second x value. So I'm going to put in the 3 this time. And when I do that, I get a y value of 8. Now I'm not quite done yet. I need to write what my solutions are. My solutions are 0, 2, and 3, 8. Now the next step says that I need to check my solution. I can do that in two ways. I can sub in the x's and y's and make sure that it checks in both equations. So remember, since we have both of our equations in y equals, and we have to do that to solve, we can go ahead and put them in y equals and check the table to make sure that there is an intersection at those points. We can also trace on the calculator to trace the intersection and make sure that that is a solution. Or we can sub in our x and y values in place of x and y in both equations with both solutions to make sure that they check in all four of those situations. So those are all your options for how you want to check your solution, and we'll go over this more in class. Have a good night. See you tomorrow.